Hi everyone. Today's our topic Geography Lesson 2 Land, Soil and Water Resources. Land, soil and water are the three most important natural resources. The entire life depends on them directly or indirectly. All three resources are finite, that is, they are limited in supply. Therefore, we need to utilize these resources in the best possible way, ensuring maximum benefits with minimal waste. If we overuse or misuse them, a time may soon come when life on Earth will become impossible. Land resources. Land makes up only 30% of the Earth. The rest is covered by oceans and seas. Of this land, only a fraction is habitable by humans. The rest is made of vast deserts, dense forests, and rugged mountains. The rocky slopes of the mountains, low lying areas prone to flooding, dry and sandy desert areas, regions covered by glaciers, and thick forested areas are generally sparsely populated or uninhabited. In fact, 90% of world's population lives on just 30% of the land area. Plains and river valleys are the most densely populated areas of the world as they offer suitable land for agriculture. They are also easy to build on and live in. Classification of land. On the basis of relief, plains, mountains, and plateaus. On the basis of the fertility of soil as fertile and barren land. On the basis of the development of that area, rural and urban land. On the basis of ownership of the land, private, community owned or government lands. Private land belongs to an individual. Community land is owned by a group of people in a community or in a community for common uses like collection of fodder, fruits, nuts or medicinal herbs. These lands are also referred to as common land or common property resources. On the basis of the use we put it to arable land. Arable land which is suitable for crop production. Pasture land used for grazing animals. Fallow land which can be cultivated but has been left unused for the season. Cultivable waste. This land which can be cultivated but which can be lying fallow for more than 5 years. Forest is nothing but natural vegetation. Land use. We use land for various purposes such as agriculture, forestry, mining, construction of residential, institutional, and industrial structures for laying roads and railway lines. The use of land is determined by physical factors and human factors. Physical factors such as topography, soil, climate, minerals, and availability of water. Human factors such as population density, availability of capital, and technology are also some important determinants of land use pattern. In India, the pattern of land use is as follows. Total land area of India is 3.28 million square kilometers. In that, 43.41% of the land area is net zone area. Forests occupy 22.57% of land area. 6.29% of the land is wasteland. 7.92% of the land is used for non-agricultural purposes. 3.45% of the land is pastoral land. 1.1% of the land is tree crops. 4.41% of the land is cultivable waste. 3.82% of the land is fallow other than current fallow. 7.03% of the land is current fallow. This information is according to the Ministry of Agriculture, Government of India. Today there is a change in land use pattern, with the people encroaching upon common lands to build commercial, industrial, and residential structures in urban and rural areas. The size and extent of agricultural and forest lands are decreasing rapid rate. The number of people and their needs are ever growing, but the availability of land is limited as it is a fixed resource. As pressure on land increases, it usually leads to land degradation. Land degradation. Over exploitation of land resources and concretization causes land degradation. Landslides, soil erosion, and desertification, which are major threats to the environment. Land degradation refers to the decline in productivity of cultivated land or forest land. Generally, land degradation results from unsuitable and unscientific land use. Factors responsible for the degradation of land include excessive exploitation of land, deforestation, clearing fertile land for settlements, slashing and burning the trees for agriculture, abandoned mining sites and surface mining toxicity in the landfill, untreated industrial effluents and concretization. Conservation of land resource. To ensure the natural resources are not depleted and to maintain ecological balance, the present rate of degradation of land resources must be checked. Afforestation, land reclamation, regulated use of chemical pesticides and fertilizers, planting of shelter belts, controlled mining, checks on overgrazing are some of the common methods used to conserve land. Soil. Soil is the unconsolidated covering of the rock particles that covers the surface of the earth. It consists of weathered particles of rocks brought by the agents of erosion like water, wind, and glaciers. It is also consists of decaying organic matter and minerals. Soil varies in color, texture, fertility, and content. The type of landforms and the nature of the parent rock determine the type of soil. Fertility of the soil refers to its ability to produce vigorous growth in plants. The right mix of minerals and organic matter with the ability to retain the correct amount of moisture determines the fertility of the soil. Soil forms very slowly. The time taken can range from 200 to several thousand years. A soil profile. The various layers in the soil are called soil horizons. The manner in which these horizons arranged in a soil is known as soil profile. The soil profile is different in different places. The main layers or horizons in the soil are A. Topsoil. This layer is dark in color, has a fine texture, has a high content of organic matter, and is vital for plant growth. This is the topsoil. Next, B horizon, subsoil. This is a layer just below the topsoil. It consists of sand, silt, and clay, but has only minor amounts of organic matter. Parent material, C horizon, consists of unconsolidated rock material. It has no humus nor does it have any soil structures. Next, bedrock. D or R horizon. This layer lies at some depth below the sea horizon and consists of solid rock. Next, soils of India. According to the Indian Council of Agricultural Research, has classified the soils found in India into 8 groups. Alluvial soil. This is a rich and fertile soil formed by the depositional action of rivers. Rivers transport eroded material from their higher reaches and deposit this material on their banks as they reach plains. This fertile alluvial soil supports cultivation of crops. In India, we can find rich deposits of alluvial soil in the vast Indo-Gangetic plains and the deltaic regions of the peninsular belt. It covers almost 24% of India's land area. Black soil. Black soil is also known as Reger soil or cotton soil. It is found in and around lava plateaus. This deep and clayey soil swells when it is wet and contracts when dry. Therefore, it develops wide cracks during summer. It is ideal for the growth of cotton. In India, it is found in the basaltic Deccan Plateau, in the states of Maharashtra, Madhya Pradesh, parts of Gujarat, and Karnataka. Telangana, Andhra Pradesh, Tamil Nadu, Uttar Pradesh, and Rajasthan. Black soil is also considered good for the cultivation of cereals, pulses, oil seeds, citrus fruits, and vegetables. Red soil. Red soil is sandy and red in color. The redness is due to the presence of iron oxides in the lowlands. They are normally fertile, but in the dry uplands they are less fertile. It is suitable for the growth of millets, cotton, wheat, onions, and potatoes. In India, red soil is found in the periphery of the black soil regions in the states of Odisha, Madhya Pradesh, Tamil Nadu, Telangana, Andhra Pradesh, and Kerala. Laterite soil. Laterite soil is formed due to intense leaching in regions with heavy rainfall. The soil is not naturally fertile as the topsoil along with the humus is washed away by heavy rainfall. To make this soil cultivable, it has to be treated with fertilizers. It is used for growing jute, millets, fodder crop, etc. It is also used for brick making in India. It is mainly found in coastal Maharashtra, Karnataka, Kerala, Odisha, Tamil Nadu, and West Bengal. Arid and sandy soil. This soil is found in the dry regions. The color of this soil varies from dark shades of reddish brown to pastel brown. It has very low moisture and humus content as it is found in the dry deserts with sufficient irrigation. The soil can be made cultivable. In India, it is found in western Rajasthan. Peaty and forest soil. In the regions where there is dense vegetation, we can find peaty and forest soil. This soil is rich in humus as the organic matter that accumulates in the forest decomposes to provide the same. In India, we can find this type of soil in the forests of Jharkhand, Bihar, Uttaranchal, and in the evergreen forest of the Western Ghats. Next, conservation of soil. The removal of topsoil is called soil erosion. If unchecked, it can even lead to depletion of soil or soil degradation. Both natural factors and human activities can lead to soil degradation. We know that soil is a vital resource which is responsible for the sustenance of all plants, animals, and human beings. All efforts should therefore be made to prevent soil degradation and conserve soil. Some methods of soil conservation are mulching. The bare ground between plants is covered with a layer of organic matter like straw or peat to prevent loss of moisture from the soil. This process of conserving soil by retaining the moisture in the soil is called mulching. Contour bonding. On hillsides, stones are used to build barriers across the slope, following contours. Contours are imaginary lines connecting places that lie at the same altitude. Trenches are made in front of the barriers to collect water. This way of preventing soil erosion is called contour barrier or contour bunding. Plugging. Rocks are piled up to slow down the flow of water. This prevents erosion by plugging the gullies to prevent soil erosion. Terrace forming. Terraces are made on steep slopes to that flat surfaces are available to grow crops. The terraces reduce runoff and soil erosion. This method of conserving soil and utilizing hill slopes to grow crop is called terrace farming. Intercropping and crop rotation. Scientific methods like intercropping and crop rotation also help conserve soil. Intercropping refers to growing different crops in alternate rows and sown at different times to protect the soil from rainwash. Crop rotation, that is, growing different crops in the same field and after the other, also helps to conserve soil. Shelter belts. In the coastal and dry regions where winds of high speed can blow away the topsoil, rows of trees are planted around farms. These trees check the wind, prevent soil erosion, and act as shelter belts. Other methods: afforestation, the increased use of organic manures, and resorting to sprinkler and drip irrigation in the place of flood irrigation can also check soil erosion. Water. Water is a vital, renewable natural resource. Three-fourths of the earth is covered by water. This water is of two types, salt water and fresh water. The oceans occupy two-thirds of the earth's surface and support a rich variety of marine plants and animals. The salinity in marine waters makes it unfit for human consumption. However, countries of the Middle East are using desalination plants to make marine waters fit for human consumption. Distribution. Fresh water accounts for only about 2.7% of all the water on the earth. Most of this occurs as ice sheets and glaciers in Greenland, Antarctica, the Arctic region, and lofty mountain peaks. Only 1% is readily available for human consumption. Fresh water is found as groundwater in wells, springs, and geysers, as surface water in rivers, lakes, and ponds. It is also found as water vapor in the atmosphere. Fresh water is therefore a critical resource. The quantity of water found on earth is fixed. It is found in different states or forms like solid, liquid, and gas, and is in constant motion, changing from vapor to water, water to ice, and back again to water. This continuous movement of water from the land to ocean to the atmosphere and back is called the water cycle. Uses of water. Humans consume a lot of water. 70% of the human body consists of water. Water is primarily used for drinking and washing. It is also used for productive purposes like irrigation of fields, generation of hydroelectricity, using water stored in reservoirs and dams, industrial needs, recreational needs. Water resources of India. India has abundant water resources, yet large parts of sorry, yet large parts of the country suffer from several water scarcity. This is because water resources are unequally distributed in India, both seasonally and spatially. India has several mighty rivers like the Ganga, Brahmaputra, Godavari, Krishna, and Narmada. The rivers that flow from the Himalayas are perennial rivers, like the Ganga and its tributaries, and the Brahmaputra are snow-fed rivers. These rivers experience flood during the summer months when snow starts melting in the mountains. The rivers of the Deccan and the South are seasonal rivers that depends on the monsoon for their water. They flood during the monsoon and have hardly any water during the hot summer months. To control the annual summer floods of the northern rivers and to put its water to better use, multi-purpose projects were started by the Indian government. Dams were built on the rivers. These dams served the multi-purposes of flood control, providing water for irrigation, generation of hydroelectricity, providing drinking water and recreation. Some of the major multi-purpose projects in India include the Bakra Nangal project, the Damodar Valley project, the Hirakud project, the Nagarjuna Sagar project, and the Narmada Valley project. Indian agriculture is increasingly dependent on irrigation or artificial methods of supplying water to the crops. The main sources of irrigation in India are irrigation canals, wells, tanks, and tube wells. The problem of water pollution has started assuming challenging proportions. The major contaminants in water are partially treated or untreated sewage, chemical fertilizers used in the agricultural sector, and industrial effluents discharged into the water bodies. They pollute water with bacteria, parasites, viruses, and toxic chemicals like pesticides. Most of these chemicals are non biodegradable. They enter human bodies through the water and cause diseases. Conservation of water resources. Scarcity of water is a major problem in many parts of the world. Most of Africa, West Asia, South Asia, parts of Western USA, Northwest Mexico, parts of South America, and Australia are facing considerable shortage of fresh water. In part, this scarcity has been caused by the sharp increase in population and the consequent increase in demand for water. This situation is made worse by other factors like the drying up of water sources and water pollution, variation in seasonal or annual precipitation, over-exploiting, and wastage due to negligence. So, today, conservation of water is a global need. Ways to conserve water. Water pollution has to be brought under control. For this, it is essential to treat effluents suitably before discharging them into water bodies. Afforestation will not help reduce runoff but also replenish underground water by enabling percolation. Rainwater harvesting is another method to conserve water by saving surface runoff. Scientific and regulated irrigational methods will prevent wastage of water. Mulching and plugging gullies also help conservation of water. In dry regions with high rates of evaporation, drip irrigation and sprinkler should be adopted. Thank you.